So as mentioned on the very first day of class, the overall goal of this course is for you to be able to derive the equations of motion of a given mechanical system that can be represented as a system comprised of particles and or rigid bodies. And so the first step in this process of solving for the equations of motion is describing the motions of the different components in that system, particularly their position, their velocity, and acceleration. So we're going to start out this course with kinematics, which is the study of the geometry of motion. And essentially, by the end of our study of kinematics, we're going to move forward and start to understand how forces cause that motion or how motion generates forces. But before we can move forward with defining motion, we first have to introduce the concept of a reference frame. And that's because without a reference frame, motion doesn't make sense. For instance, if I asked you for directions to the library on campus here, in order to tell me where the library is, you would first need to know where it is that I'm located. And that's because if I were in eLab, the directions you would give me would look maybe something like this, whereas if I were in the Fine Arts building, the directions would look like this. And that's because when you define the position of a body in space, or in this case, a library on a campus, position is defined relative to a reference point. And in addition to a point, we also need a reference direction. So for example, we also need to establish that this direction is, say, east, and this direction is north. So in order to describe the motion of a body or a point in space, I first need to define a reference frame. In this example, I'm going to call this reference frame frame A. And so the first thing I need to do is to draw a reference point or origin for this frame, which I'm going to draw here, and I'm going to call that point O. In addition, I need to define vectors, and enough vectors that span the entire space in which my body will be moving. Now in this class, we're only going to consider systems that move in a two-dimensional plane, which means that I only need two vectors. And with those two vectors, as long as they aren't located on top of each other, I can define any point in a 2D space. And so by convention, I'm going to use two unit vectors that are perpendicular to one another. And I'm going to call this unit vector A1 and this one A2 because they belong to frame A. Now, as a quick aside, there's many different conventions that you can use to indicate vectors. For example, I could draw an arrow above the variable. If I were typing, I could make that variable boldface. But the notation that we're going to use in this class in order to define a vector is an bar under the variable. And it is expected that in homeworks and quizzes that you follow this notation. And so in addition to defining one reference frame like we've done here, we can actually define multiple within a space. So for example, I can draw another reference frame. I'll call it, say, frame B over here. It will have an origin. I'm going to give it, call that origin N, and it will have two unit vectors again. Oh. And I will call those B1 and B2. And so this week, we're going to focus on defining the position or the location of a rigid body within a single reference frame. So perhaps the point on the rigid body that I want to define here is I'm going to define this position vector. In the next week, we're going to come back to defining multiple reference frames and learn how we can actually use more than one reference frame in order to make our lives easier when describing complex behaviors. And so in the next videos, what I'm going to focus on is how to define the position, the velocity, and the acceleration of a particle and a point on a rigid body within a single reference frame. So for example, we're going to focus on describing position, velocity, and acceleration for a system like this.